afternoon, welcome back. Today I will see the group 13 P block, that is boron family. Boron family in detail. Right. Boron elements are aluminum, gallium, indium, thallium. This much only we will see. Boron atomic number 5. So this is a non-metal. Aluminum is metal. Aluminum onwards metals. Okay. Then non-metal is okay. What is the normal general configuration? NS2 and NP1. That is outermost. Total 5. That is 1s2, 2s2, 2p1. Aluminum is 13. Aluminum is 13. Gallium is 31. 31 plus 14, 18, 48, 49. 49 plus 32, 81. Okay. These two are non-D block. In between the gallium onwards, D and Fr will start. Aluminum is a metal. No. Isotopes of the boron is B10 and B11 are the isotopes of boron. B10 is only 19%. B11 is 81%. They have more nuclear applications. It is a rare element. Rare element means 10 ppm is availability in the earth crust as orthoboric acid, then borax. Orthoboric acid means H3BO3. Borax means Na2B4O7 10H2O. One more is there, 4H2O fellow also. Na2BO4 H2O is that is also Indian borax. That is called kernite. Reference is only in H2O. So B10 and B11 are the isotopes. B10 is the 19%, B11 is 81%, 10 ppm is only occurrence. This is this one about the boron. So a configuration is 5 NS2 NP1. So this is about the appearance, means general configuration, then boron availability, then isotopes and all. If you see the aluminum is 13. Here also know the D block this thing. Whereas this is most abundant. Most abundant means its availability is around 8.3%. 8.3% is third most. First is oxygen, 45%. Then silica. First is oxygen, then silica. Oxygen is around 45% and silica is around some 27.7% or 28%, and then this is 8.3% more abundant. This is a pure metal. Aluminum is a pure metal. Availability bauxite. That is called aluminum Al2O3 2H2O. And one more is the cryolite, Na3 aluminum fluoride, hexafluoride. Madhya Pradesh, availability is at Madhya Pradesh, then Orissa, Kerala, Karnataka, This is at Ladakh. Main is Ladakh, boron. Whereas the other gallium, indium, thallium are less abundant. They are metals less abundant. That is this thing. So electronic configuration is same, ns2 np1 for all these things. Whereas first two are the only the p, then d is coming, then 31 plus 18, then the f is also coming for this thing. So because of that the properties are changing, and so if you see the atomic radii and this thing, atomic radii is for boron 88 pm, all pms only I am writing. Whereas aluminum is 143, gallium is 135, 167 and 170 is thallium. PM is picometer. So increasing is okay, we can understand, but the decreasing is because of the D is D block is coming. D block is not shielding properly, so only positive charge is pulling. So atomic radii is reduced here. Atomic radii is small deviation. Then further it is a continuation, and there is no deviations and all. That is about the atomic radii. Then electronegativity, ionization therapies. Ionization therapies, if you see, ionization therapies are general trend is it will reduce. That means easy to remove the electron. Whereas the other things are inability of D and F blocks. So ionization enthalpies are delta H1, H2, H3 are expected. There are three ionization enthalpies. Electronegativity, first boron to aluminum it decreases, then it will be, if you see ionization enthalpies are the decreasing, the first one, only one we will consider. Suppose boron to alumina it is decreasing, whereas second and third reaction there are some small abnormalities. Whereas electronegativity boron to aluminum it is decreasing, boron to aluminum it is decreasing, then aluminum onwards again it is increasing, decrease and increase. Electronegativity, small differences. Whereas the if you see boron, one of the most critical this thing is boron melting point is very high, melting point of boron is melting point of boron is very high, something like a 2500 and 2500 Kelvin, 2450 60 Kelvin. Whereas aluminum is reduced 933 Kelvin only. Interestingly, gallium is at room temperature just 25 degrees is solid, but whereas just that is around 303 afterwards it is a liquid. In summer it is a gallium is a liquid metal, whereas in normal seasons that means below 30 degrees centigrade it will be a solid metal. Gallium is a melting point abnormality. Okay, so that is about the physical properties. If you see the chemical properties, ionization potentials, that is oxidation states, everybody knows that is 1, 3 it will be there, whereas alumina will be 3 and progressively increasing heavier elements, aluminum, gallium, indium, thallium and all. Whereas the boron is normally 3. So that is the because of the d orbital and f orbital this thing. Boron normally boron trichloride, boron trifluoride, like that many boron these things are there. But whereas when it is reacting with the boron trichloride with ammonia, it is becoming a tetrahedral. That means 4 also. Boron is a planar, chlorine, 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 and the ammonia, that is the ammonia is donating the one lone pair here, this thing. So it is a tetrahedral. Boron, whereas aluminum is AlCl3nR is a tetrahedral, but dimer it is forms most of the time forms a dimer. Whereas BCl3 and lone pair of electrons ammonia to form the BCl3 ammonium, it is called ammonia lone pair is giving to the boron. And BFP3 is Lewis acid. Remember, BFP3 is Lewis acid. Then tomorrow we will see the what is the reaction with the air. Normally the always reaction with the oxygen, reaction with nitrogen, reaction with acids, reaction with alkalis. These are the normal for any compound and all. So boron or aluminum, anything will form with oxygen is oxides, with nitrogen nitrides, with the acids some resistivity and this thing. Tomorrow we'll see. Thank you.